All right. So I am Carrie Troy. This is Aaron Thompson. We're both from Purdue, different sides of campus. This is work that was kind of an unusual Sea Grant project where it was funding for actually 3 different Sea Grants. So Wisconsin, Michigan, and then Illinois, Indiana, were the Illinois, Indiana portion. We had some collaborators at both of those Sea Grants from University of Wisconsin and Michigan Tech University. A lot of different people, and I'm just going to talk about my part. Aaron will briefly introduce his part, and there's a lot more going on behind the scenes. So as Robin mentioned, the motivation for shoreline work in the recent times has been this dramatic increase in lake levels, basically going from a record low in January of 2013 to a record high in July of 2020, which is kind of like geological whiplash for a system like Lake Michigan. And there was a ton of shoreline change and damage and destruction. And next slide. Our questions, these are just kind of broad questions that we ended up looking at for the project. Which parts of Lake Michigan as a whole have high erosion potential? Can we model those shoreline changes for Lake Michigan? And then Aaron's part and some of the other social scientists, how do we bring communities into the process for developing more resilient shorelines? Some of the things that I worked on, one of the first things that we did is we realized that there was a shortage of the data that we needed to quantify how shorelines were changing in response to the changing conditions. So we went to outer space, figuratively. We used satellites, and we developed a new algorithm where you can use some of the new multispectral satellite imagery. We now have commercial satellites available that fly around the Earth multiple times in a week. With resolution on the order of like 2 to 5 meters. Okay, so you can actually sense shoreline positions and changes over very fine time scales. So we wrote a paper related to that. And an example of what you get with this method and the new technology, the new satellites, is the top graph there, which is showing you the shoreline position. So a larger shoreline position is lakeward. So that's a good beach condition. And then the smaller shoreline positions are, basically eroded. And you can see that correspondence very closely between the rising water levels and then the receding shorelines, right? But this sort of data is basically unprecedented in terms of, being able to extract shorelines from space. The other important thing that drives shoreline change, or that really drives shoreline change, are the waves. And so if we go to the next slide, one of the things that we looked at was how shoreline changes are varying over the entire lake. And we didn't do, every single shoreline of Lake Michigan. We did the locations that you're seeing here. So we mapped the shoreline changes from 2013 to 2020. That's basically the water level increase period. And we looked at how they vary geographically. And then we had a bunch of explanatory factors over there that we looked at to try to figure out why different areas erode more than others for the same water level rise condition. And one of the main takeaways is that it's the waves. Basically, the eastern part of Lake Michigan actually sees some of the biggest waves in the lake, and they were some of the most eroded beaches in response to the rising water levels. Next slide. So once we sense the shorelines, that's the yellow line here. My student, very sharp student, developed a shoreline change model that basically simulates the shoreline position in response to water levels and waves. And there's a lot of details that go into this model. I'll refer you to the paper. But basically, this was a new model that grew out of the fact that ocean coasts see tides on a daily basis, right? 12 to 24-hour timescales when they have sea level rise. But, lake level rise in the Great Lakes is like sea level rise on steroids, right? Like 2 meters in 7 years. For sea level rise, we typically think about like 1 foot per century. Okay, so that's what necessitated this model, was basically the need to account for the changing water levels. And the model is pretty successful. So I think now we'll shift to Aaron.
Sounds good. Good afternoon, everybody. So just to jump in real quick. So a couple of years ago, actually through some former colleagues of mine with the University of Wisconsin, got recruited into this project. I'm a social scientist. I do a lot of work in water quality and inland lakes, but working on the Great Lakes around these erosion conditions, it's people, I've spent the last 2 years learning from Robin, learning from Carrie about kind of some of these larger challenges and specifically the issues that communities face as they are planning for these. A lot of the work that we're doing right now, the slide that's up on the screen, we have a survey out right now to 500 landowners from Gary, Indiana to Long Beach, Indiana. So the entire coastline's represented. We're looking at their, I've spent the last 2 years trying to figure out how to take all of what Carrie's informed me of, turn it into language we can actually share out to the public, and then collect information about their preferences for the future. And I think that's my 2-minute warning. Right. And I think that's about where we're going to stop on this. Right. So the idea behind this is that we'll use this information to help communities that are considering solutions to these issues. There are a lot of ongoing challenges. We continue to build relationships with these coastal communities with the hopes of continuing to work with them on addressing these, even as the water levels drop back down. So I think I'm turning it back over to you to finish, right?
Sure. Thanks, Aaron. So I think that wraps it up. Next slide. Next step. So we're trying to publish some additional results from the project, some of the stuff that you saw today. Finalize the survey collection and analysis that Aaron is working on, and then try to leverage all these results for more funding. And thank you to Sea Grant and also to the DNR for funding a lot of this work here. Thank you.
Thank you.